Hello, now let's learn theorem related with corresponding chords of congruent arcs and a theorem related with corresponding arcs of congruent chords. Let's see. Prove that corresponding chords of congruent arcs of a circle or of congruent circles are congruent. Okay. As per this statement, let us consider a circle with center O, and let's consider an arc APB and an arc CQD such that arc APB is congruent with arc CQD. Okay, let's mention what is given and what to prove. Given in circle with center O, arc APB is congruent with arc CQD. Then to prove corresponding chords of congruent arcs, means chord corresponding to arc APB will be called AB and chord corresponding to arc CQD will be chord CD. To prove chord AB congruent chord CD, chord AB congruent chord CD. Okay, we are interested to prove. Now information is insufficient, we need construction. Draw seg OA, seg OB, seg OC and seg OD. Okay. Now if we draw seg OA, seg OB, seg OC, seg OD, we get a pair of triangles and we can prove these triangles are congruent with each other. Now first of all, let's discuss how they are congruent with each other. We may prove OA is congruent with OC, OB is congruent with OD because these are radii of same circle. And now as arc APB is congruent with arc CQD, and therefore measure of arc APB equals measure of arc CQD, and measure of minor arc means measure of central angle subtended by that arc, means we can prove angle AOB congruent angle COD, and therefore from the nature of this diagram, triangle AOB is congruent with triangle COD by SAS test. And if two triangles are congruent, then their corresponding elements are congruent. We are interested with chord AB and chord CD. We may declare their chord or seg AB congruent seg CD since CSCT, and seg AB is nothing but chord AB and seg CD is nothing but chord CD. Now let's mention this in proof. Okay, arc APB congruent arc CQD, since it is given and therefore measure of arc APB must be equals measure of arc CQD, and therefore measure of arc APB is nothing but angle AOB, and similarly measure of arc CQD is nothing but angle COD. Okay, number one, by definition of measure of minor arc or an arc, and therefore in a triangle AOB and triangle COD, okay, AO congruent CO, BO congruent DO, since radii of same circle, okay, let it be first equation, it be second, angle AOB congruent angle COD from 1 and 2, and therefore triangle AOB congruent triangle COD by SAS test, and therefore seg AB is congruent with seg CD, since corresponding sides of congruent triangle CSCD, and therefore seg AB is nothing but chord AB is congruent with seg CD, means chord CD, chord CD. Hence the proof. Here we proved corresponding chords of congruent arcs of a circle or congruent circles are congruent. Conversely, we can prove that corresponding arcs of congruent chords of a circle or of congruent circles are congruent. Okay, let's mention here. Next, prove that converse of this statement. Okay, prove that corresponding arcs of congruent chords of a circle or of congruent circles are congruent. Okay, you may know the difference. Here was a word chords, here is a word arcs, corresponding arcs of congruent chords of a circle or of congruent circles are congruent. Means in this case we need a circle such that chords are congruent. Means here in this case leading circle with center O, chord AB is congruent with chord CD. Okay, and let arc APB and arc CQD be their corresponding arcs. We are interested to prove arc APB is congruent with arc CQD. Okay, let's mention here given in circle with center O, Yes, we have chord AB, congruent chord CD. And what to prove? To prove arcs corresponding to congruent chords are congruent. Here arc APB correspond to chord AB. That's why arc APB is congruent with arc CQD. Arc CQD. Okay. To prove arc APB congruent arc CQD. Again, information is insufficient. That's why we need construction. Construction. Draw seg OA, seg OB, seg OC and seg OD. Okay. Seg OA, seg OB, seg OC and seg OD. You may note there is exchange of given and to prove in these cases. Same construction is there, and as there is exchange of given and to prove, proof will be different. Proof. Now from figure you may note seg AB is congruent with seg CD because it is given. You may note OA is congruent with OC, OB is congruent with OD since these are radii of same circles, and therefore triangle just like that AOB is congruent with triangle COD. Now in this case test is yes test, and if two triangles are congruent then their corresponding elements are congruent. We are interested with arc APB and arc CQD, but we are going to consider their central angles. As central angles will be congruent, then arcs intersected by those central angles which are congruent will be congruent. Okay, let's mention here in a proof. In a triangle AOB and a triangle COD, yes, AB is congruent with CD since it is given. Then OA congruent OC, OB congruent OD since radii of same circle. Radii of same circle. Okay, and therefore triangle AOB is congruent with triangle COD by yes test. Okay, and therefore angle AOB is congruent with angle COD. Let's call it as equation first, since corresponding angles of congruent triangles CACT. But angle AOB equals measure of arc APB and angle COD equals measure of arc CQD. Common curly equation second by definition of measure of arc. Okay, and therefore measure of arc APB equals measure of arc CQD from 1 and 2. And as measures of arcs are equal with equal radii, therefore such arcs are congruent. Therefore, arc APB congruent arc CQD. Hence the proof. Okay.